Please pause and copy everything you see on the screen right now. So, to begin the class, we'll be looking at inverse functions of some trig functions, sine, cos, tan mostly. To remind you of inverse functions, we're going to look at x squared and its inverse function root x. So to get a graph, I'm going to take the blue here, blue curve, and reflect it in the red line. So you imagine the red line is a mirror, and you reflect and get something like, let's see, so you get that roughly. But if you reflect this arm here, you'll get this part. Now, this you'll recognize as the graph of root x. Problem is we want this inverse to be a function. Okay, so we have to make a choice here. Okay, you want it to pass what's called the vertical line test. So every vertical line can only touch it once. So we're going to choose the top arm or the lower arm. And as you know, we choose the top arm. So we delete this bottom bit, and there we go. Put a little arrow here to indicate it goes forever, and blah, blah, blah. Okay, so we had to make a choice there. We had to do some domain restriction of the original function. So we'll be doing that again when we find the inverse of sine of x. So pause and copy. Here's sine x and the diagonal line y equals x. Now, when I do this reflection, I'll give you a better picture below. I'll be getting something that looks sort of like this. Oh boy, shouldn't be more than vertical. Something like this. And then down like something like this, maybe. Okay, you'll see that we took only part of sine x, not the dotted part. So the dotted part we discarded, and we kept just the piece between minus pi over 2 and pi over 2. So we made a choice here. We could have chosen other pieces of sine of x, but this is the standard choice. So here's what I'm going to call arc sine of x. This is also known as sine inverse of x, but I'm going to use the arc sine notation, and I'll tell you why later. So here's a better picture of arc sine. Got a domain, got a range, and pause and copy if you haven't done so already. Okay, so you can draw pictures of arc cos and arc tan as well. And I summarize here. So pause and copy all this stuff. Now. Okay, I guess we should add some little arrows here. Little arrow over here to indicate you go on forever, and an arrow down here to indicate you go forever. And don't forget to make note of these limits here. Okay, what it's saying is that arctan, when I go way over to the right, what I'm approaching is this horizontal line y equals pi over 2. And if I go way to the left, I'm approaching this horizontal line. Y is negative pi over 2. Okay, these will be important limits. They seem to come up a lot, actually, in this course. Okay, of the three graphs, I would say arctan is the one that is probably the most important for this class. Don't really use the graph of arc cos or arc sine. Okay, let's do some examples of calculating with these new functions. So perhaps I'll just say now that we're introducing these functions to torture NYB students. No, I'm just kidding. We're going to introduce these functions because we'll need them later. Basically, we'll be finding some integrals later on in the course, and things like this are going to appear. Or even worse, you'll do a long integral and you'll get something like this at the end. And you'll be expected to simplify. So, how do I find arc sine of 1/2? Well, maybe the easiest way is to think of this as an angle. So let arc sine of 1/2 be an angle. Okay, why am I choosing an angle? Well, if you think about sine of blah, 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 this gives a number, right? So sine takes an angle and gives you a number between -1 and 1. So it stands to reason that arc sine is going to do the opposite. It's going to take a number and give you an angle. Anyhow, arc sine, not arse sine, I wonder. Arc sine. There we go. So arc sine 1/2 is the theta. So what I will do is essentially apply sine to both sides. So you get 1/2 is sine theta. And now I have a familiar trig equation that I am going to solve. One very important snag is that we have to respect the fact that theta is between negative pi over 2 and pi over 2. Very important snag here. Okay, why is that? Well, let's scroll back up and have a look at our arc sine function, blah, 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 blah. Here we go. See, now arc sine, well, now we're going to put a theta here just to, no, never mind. Where was I? So arc sine always gives you an answer or a result between minus pi over 2 and pi over 2. Okay, it cannot give you something outside of that range. Okay, back to what we were doing. So I'm trying to solve this problem here. Solve for theta. Okay, so which theta gives me 1/2 when I apply sine to it? Okay, from my knowledge of the unit circle, I get pi over 6, right? So that's my answer to arc sine of 1/2. So it equals pi over 6. Okay, that's all very long-winded. You can do it a bit quicker just by saying sine question mark is equal to 1/2. And then find the question mark, keeping in mind that it's got to be between minus pi over 2 and pi over 2. Okay, part B. maybe I'll do it the fast way here. Sine of what angle is going to give me 0? Remembering that it's got to be between minus pi over 2 and pi over 2. Well, what I get is 0. Okay, sine of 0 is 0. Okay, this little arrow I've drawn here, that's my way of saying therefore, or implies. Okay, arc cos of 1. So cosine of something is 1. Cosine of what angle is 1? That's also 0. So arc cosine of 1 is 0. Because looking here, cosine of 0 is 1. Okay, tan arc sine of a third. Let's see. This one's a little bit longer. So what you can do here is say theta is equal to this arc sine, as we did above up here, and then sine theta is a third, and then you say to yourself, well, what triangle does that give me? So if I put my theta in my bottom left, sine of this theta is 1 over 3. So sine is equal to, you'll remember from trig, it is so ka toa. So is opposite over hypotenuse. So that's my 1 is going here, and my 3 is going here. And my adjacent can be found using Pythagoras. So Pythagoras says, let's do this more carefully. 3 squared is equal to 1 squared plus the adjacent squared. So solving this, I get the adjacent is root of 8, which is 2 root 2. Now, let's take a step back and remember what we're looking for. We want tan of this thing. So we want tan theta. Okay, so now you can see why I drew this triangle. Now I can read tan theta directly off of this triangle. Okay, toa. Tan is opposite over adjacent. Tan theta is opposite 1 over adjacent 2 root 2. Okay, here's an exercise or 3 for you to try, and we'll pick it up in the next video.